So let's start with homologous series analysis. Let's go. So A, I see carbonyl there. I see that carbon double bond oxygen and is within. Therefore, I'm seeing a ketone. And if they say now give the name of the ketone, I'm going to need that unknown. I'm going to need that unknown and put that the position over there, the number over there, and then B, I see that hydroxyl group over there. So that means this is a alcohol. It's an alcohol, and I'm going to need that suffix of anol and put the number over there. Compound C, I see a carboxylic group. That is a carboxylic acid. So I have carboxylic acid. And if I were to give it a name, I would need the suffix of anoic acid then. Ethyl propanoate there. Ethyl propanoate, the suffix is giving it away, and this is an ester. It's an ester. Okay, so that's homologous series with the suffix there. Okay, next, molecular formula, not molecular formula, excuse me. Functional group, structure, and name. So the functional group of a ketone is this carbonyl group there, this thing. So you put it there just in case the question says give the structure of the functional group, not the whole thing, just the functional group structure and or the name. Just put it there. You have it there close. The structure of the functional group of alcohols, the hydroxyl group. This is it over here. This is a hydroxyl group. This is a hydroxyl group. The structure of the functional group of the carboxylic acid is a carboxyl group. This is a carboxyl group here. There's a carboxyl group here. There's a carboxyl group here. And then now, and lastly, the structure of the functional group of esters. This is ester linkage. It's an ester linkage there. It's an ester linkage there. So I have that ester linkage. This is an ester linkage there. All right. Then from there, then let's. Okay, the next thing that we do here is that let's do general molecular formula analysis with the type of isomer that we can expect there. So for compound A, which is a ketone, the general molecular formula is CnH2nO, the same general molecular formula as an aldehyde there. So now with that, we say that ketones are functional isomer of aldehyde there. So in other words, if the question says now draw the isomer of that compound, of compound A, then you must draw an aldehyde with the same number of carbons there. It will be the functional isomer of an aldehyde. They have the same general molecular formula there. Then compound B, general molecular formula there, we are going to be having, it's an alcohol, so we are going to be having CnH2n plus 1 OH there. And with the hydroxyl group there, although we have said that for chain isomer, you can do chain isomer with all of them. So for example, compound B, you can do chain isomer by removing that branch, by unbranching it there, and turning that chain into a straight chain. But then with the homologous series specifically, with the functional group specifically, that hydroxyl group, it can change positions there. It's on position 1 right now, so you can put it on carbon number 2 there, so to get a positional isomer there by shifting the hydroxyl group position there. Even that methyl substituent can be shifted as well. So yeah, but then just speaking about the functional group there. Okay, and then compound C, we have a carboxylic acid. Carboxylic acid general molecular formula is CN H2N there. While we are still at that, the last one is an ester, and then they have the same general molecular formula CnH2nO2, and then this is because a carboxylic acid is a functional isomer. Is a functional isomer of an ester. The functional isomer of an ester, and then also ester as well. It goes both ways. Functional isomer, also ester is a functional isomer of a carboxylic acid there. So it means that when a question wants you to draw the structure of a functional isomer of a carboxylic acid, you would draw an ester, and then if they want a functional isomer, an isomer of of an ester, you draw a carboxylic acid with the same amount of carbons there. If you keep the number of carbons the same, and then they will have the same molecular formula, just with different functional groups, hence the definition of functional isomer there. That's the definition of functional isomer there. Okay, the next thing to do here, so we did homologous series, functional group, homologous series, functional group. So we did homologous series with the suffix, functional group, the structure, as well as the name of the functional group. We did the general molecular formula and the types of isomers you can expect. Now it's time to we must give them the names, give the structures the names there. Let's start with compound A. Compound A there, let's put the things that, that's the structure there, but then let's only write down the parts that are important there. So basically what I have there is 1, 2, 3, 4, 5 carbons there. 5 carbons with this over here, this carbonyl group there. This carbonyl group, when you look at it there, it's closer to the left hand side. So we start numbering from the left. 1, 2, 3, 4, 5 there. No substituents here, no halogens or no branches, so we are done. So now what we need is that we needed that part whereby we said that the ketone suffix will be unknown. Then we say, okay, we have 5 carbons in the stem, so 5 carbons in the stem, that's pent, and then the suffix is unknown. But before we put the on, we say that a carbonyl is on carbon number 2, and then we put the on there, so we have pentan 2 on there. IUPAC name. And then compound B, let's do the same for compound B. Let's put the important parts. Let's see. So we have basically there we have 1, 2, 3, 4 carbons, and then on this carbon over here we have the hydroxyl group, and then on this carbon over here we have that methyl branch. We have a methyl branch there. So now we give priority to the functional group there. Remember, I'm just drawing it without the hydrogens there. This is the same there, just to highlight the important parts there. So now the hydroxyl group there, must remember the hydroxyl group takes the highest priority. The functional group takes the highest priority. So if it's on carbon number 1 on the right hand side there, there's no negotiating there. We just say this is number 1, this is 2, this is 3, and this is 4, just like that there. And then now we start with the substituent there. We start with the branch there, and then we say that it's on carbon number 3. We have a methyl branch on carbon number 3. We have 4 carbons in the stem. The stem name for 4 is but, and then we go to that analysis of the suffix. The alcohol will end with anol, and then we'll say anol. But then now on carbon number 1, that's where we have the hydroxyl group then, and then we say all. So it's 3-methyl-butan 1 all there. Even the IUPAC name is telling us, it's saying to us that we have anol, an alcohol but with 4 carbons, an alcohol with 4 carbons with the hydroxyl group on carbon number 1. But on carbon number 3, we have a methyl branch there. This is describing what we have above there. Okay. Now, compound C there is clear. So we have a carboxylic acid. The carboxylic acid, however, it does not have any bromose or any methyl branches there. So it's just a carboxylic acid. The carboxyl group is over there. And then with the carboxylic acid, same as an aldehyde, the functional group is always there at the end there. So it means it's always carbon number 1 there where it is there. So there's no negotiating there. We just have to, in this case, we just have to count how many. But then before we get to that, we start with the suffix. It's supposed to end with anoic acid. So it's going to be anoic acid there. Anoic acid, but what? How many carbons? 1, 2, 3, 4, 5. Then it's pent. Right, and then the ester there, compound D, is an ester. Compound D is an ester, so there we have a name, so you must draw the structure. Okay, now to draw the structure, we need the structure of the functional group. That's where we start there. We must draw the ester linkage there. So the ester linkage there, we have this. So I'm just choosing to make it face that way. There, remember, it can be either way there. As long as you remember, what you must do is you must make sure that you understand that this is the alcohol side, this is the acid side, and then when it comes to the name, this is the alcohol side, this is the acid side there. So it's not a matter of this is the left hand side, right hand side. No, alcohol side, acid side. So let's start with this one. The alcohol side has 2 carbons. F has 2 carbons. So I make sure that I have here 1 carbon, another one. That's 2. And then the acid side is propanoate. So it's 3 carbons. So it's 1, it's 2, and then it's 3 there. 3 carbons there. So now I'm done. All I have to do there is just to make sure that each carbon has 4 bonds. So this one, like that, like that, like that, oops, like that there. So this is ethyl propanoate. What does this mean? It's not about, again, it's not about what is on the left, what is on the right. It's about when you divide this over here, like this. This part that is connected to the oxygen has 2 carbons, F. And this part that is connected to the carbon double bond oxygen here has 3 carbons here. There, this can easily be on that side, and this can easily be on this side, but then you follow it where it is there, the alcohol side and the acid side there. Okay, then that's how we do the ester there. And then to take it further there with an ester, it's always just best to move it a little bit further and say, now here is our ester, and the molecular formula of this ester is we have carbons, we have hydrogens, and we have oxygens. Let's see, we have 1 2 3 4 5 carbons. These are 5 carbons, and then we have 1 2 3 4 5 6 7 8 9 10 hydrogens, 10 hydrogens, and 1 2 oxygens there, 2 oxygens there. Now when a question gives you an ester and then they say they want the isomer there, and it's going to be a functional isomer, and then they say they want an isomer, the isomer is going to be drawing a carboxylic acid. Draw a carboxylic acid that is an isomer of this. We are going to draw a carboxylic acid that has 5 carbons there. So let's stick with that. Let's stick with that a little bit there. We are going to draw a what? A carboxylic acid. So we must have a carboxylic group to start with. A carboxylic group, a carboxylic acid. We start with the functional group, carboxylic group, and then put carbon number 2, 3, 4, and 5. So we have now 5 carbons. Now let's make sure that each carbon has 4 bonds by putting the hydrogens there. There we go there. So now let's check if this is the correct isomer. We have carbons, hydrogens, as well as oxygens. Let's write down the molecular formula. The molecular formula. So it's something that you can practice as well. So even condensed structural formula you can practice as well. You can say this is CH3, CH2, 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 COO. H. This is the condensed structural formula. So like every time you get an opportunity, practice doing molecular formula, practice doing condensed structural formula, so that in the question where you get condensed structural formula, you are familiar with the condensed structural formula, that this is a carboxylic acid, and then molecular formula as well, we are familiar with that as well. So carboxylic acid and ester, you will see that they have 2 oxygens there. So they're the only ones with 2 oxygens there. So you are familiar with such there. So whenever you get an opportunity, do condensed structure, do molecular formula there. And then how many carbons? 1 2 3 4 5 carbons. Okay. How many hydrogens? 1 2 3 4 5 6 7 8 9 10 hydrogens there. C5H10O2, same molecular formula but different functional groups. So this is how you give the isomer of an ester. You draw the carboxylic acid with the same amount of carbons. So you must add all the carbons here, say it's 5, and then draw a carboxylic acid there, and then you'll have your functional isomer there. You also give it a name, and then surprisingly, is that what you realize is that this is pentanoic acid, that compound C over there. So already we know compound C is the isomer of compound D when the question comes and asks that there. All right. Now, if we were to do an isomer for a compound C, to draw the structure of the isomer for compound C, then it means that is this ester ethyl propanoate, not just ethyl propanoate, but methyl butanoate, and then also reverse that butyl methanoate. just any ester that has 5 carbons there. And then for esters, it means that we have different possibilities whereby we can have 5 carbons there. So you can either have, you see, like on the alcohol side, on the acid side, as long as the total is 5 there. So it's easier when you go from an ester to a carboxylic acid if they want the functional isomer of the ester. But if they want the functional isomer of the carboxylic acid, then we must draw an ester. Now the question is now, it has to be like, the issue becomes, it has to be just a total of 5. So like for example, ethyl propanoate is 2 plus 3. Then it means you can make 1 plus 4. It will be methyl butanoate, or 1 plus 4, even 4 plus 1, whereby you say now it's butyl methanoate then. Okay, and then to compound B. Compound B is an alcohol. We said that the type of isomer you can expect to have, there's a positional isomer there of that hydroxyl group there. For example, you would say then I have, if you keep that methyl over there, I'll just shift one thing, 1, 2, 3, 4 there. Now instead of having that hydroxyl group there on carbon number 1, and then maybe you can have it on carbon number 2, like that there. So from being a primary alcohol to a secondary alcohol. And what is even more interesting is that if you shift it to this carbon specifically here, it will be on carbon number 2 still, but then to this one specifically, then it becomes a tertiary alcohol there, because this carbon will be bonded to 3 other carbons there. So this is how you can do positional isomer of this compound. And then you can say now, because the hydroxyl is still on the right hand side, is 1, 2, 3, 4. Then the name would be 3 methyl, 4 carbons in the stem still. Then it will be butan. The suffix is still anol because it's still an alcohol. The difference just now is just the position of that hydroxyl group. Now it's on carbon number 2, is butan 2 all there. And then another possibility with this one is that, or because we already have a branch, we can unbranch. So we have 4 carbons in the stem. One of the carbons is a branch, so we can put it as part of the main chain. So take this, put it here, there, to be part of the main chain. So here it is. It's over here. It's 1. Then you put the 4. 1, 2, 3, 4. See, now it's like this branch there. We put it here to be part of the main chain, and then we have that OH over there. So we have it over here now. So 1, 2, 3, 4, 5 there. So we remove the branch, and thereby also you can say that if we remove the branch and make it into a straight chain, it has then stronger intermolecular forces that will need more energy to overcome, but that is on the side of the physical properties there. Now this isomer is we unbranch. It's a chain isomer whereby we unbranch. Usually we make a chain isomer by branching. This time we make a chain isomer by unbranching. So here, as we said, that it's a positional isomer for an alcohol, but all of them can have a chain isomer there, like we have here. Then it would be then no longer butan. So the branch is not there. The branch is removed, no branch, but then it's no longer but there. So instead, it's a pent. It's a pent because it's 5 carbons in the stem. It's a pent, and then the suffix is still anol, and then but the non-carbon number 1, and then it's all there. So it's pentan 1 all there. So this will be the chain isomer of that compound. It will be the chain isomer of that compound there. So now this is the chain isomer that you get when you unbranch. But looking at that compound, we can branch even further. It seems like that there. So there are many possibilities for having isomers there. Okay. And then now that's hence the question would be specific and say draw the positional isomer, such that maybe you change the position of the hydroxyl group to form a minor product or a major product. Now a major product just means that we move the hydroxyl group to a higher carbon order, like carbon number 2, lower carbon order, carbon number 1. That's a minor product or primary alcohol there. And then for the last one over there, we have that over there. We have we look at it there. It says now give the structure of the isomer of a ketone. I look at the number of carbons. How many carbons? 1, 2, 3, 4, 5 carbons. And then after that, I draw an aldehyde. I make it into an aldehyde. I put this carbon double bond thingy there to at the end there at the end, whereby it will be bonded to a carbon that is bonded to a hydrogen. And then when I do that, then it means now this here is a formyl group. It's a functional group of an aldehyde. This is now an aldehyde there. It's an aldehyde. So when they say draw a functional isomer of a ketone, you draw an aldehyde with the same amount of carbons there. The same amount of carbons there. So it's an aldehyde. So it means that now it will no longer be anone. The suffix now changes to anal there. So the question is always, it can be structure or name. So you must always do both. So I have 5 carbons there in the stem. So then it's pent. So this is pentanal. So the name of this isomer is pentanal. The IUPAC name of this isomer is pentanal. So the question can be give the structure or give the name. Always just do both of them there, just in case there. All right. So now I think we are at the end, because if we can recap just a little bit there, just a little bit of a recap of what we did there. I think the first analysis is the homologous series with the suffix analysis. General, and then we moved to, before we go to general molecular formula, we moved to the structures of the functional group with the names of the functional group, what they are, what the, okay, let me do this. So the second thing there is the structures of the functional groups, and then the names of the functional groups there. The questions can require, the names can require the structures of the functional groups there. And then there's the second thing. The third thing is the general molecular formulas, as well as the type of isomer that you can sort of expect from that homologous series there, from that compound there. And then the next thing that we did there was to every structure must have a name. Every structure must have a name, and every name must have a structure there. Every structure must have a name, and every name must have a structure there. So IUPAC names as well as structures from IUPAC names there. Then the last thing that we do then is to then draw the structures of the isomers, and then also give the isomers the names there. And then sometimes you find that you gave you find that the isomer that you drew is already there as part of the compounds given there. So when the question says now give a pair of isomers, you already know which ones are isomers there. So that list of things there, once it's done, then we can answer the questions now. Now let's see. 2.2.1 write down the structural formula of the functional group of compound A. I go to my functional group analysis. And I say the structural formula of the functional group of A of the ketone. I have that there. Here it is over here. Here is my carbonyl group here. So if they say the name, I would say carbonyl group. They want the structure, I give them the structure. And then 2.2.2, the name of the functional group of compound C. Now compound C, functional group, but name. The name, and then it's a carboxyl group there from my functional group analysis. It's a carboxyl group that I have there. And then 2.2.3 then says the letter that represents an ester. Then we go to our homologous series analysis. Which one is an ester? That's compound D. The letter that is an ester is compound D. And then 2.2.4 says IUPAC name of compound B. Did we give a name for compound B? Then we go to the names when we were naming them. Not when we were naming the esters, when we were naming the compounds themselves. So here it is over here. We named it here. We said we have a hydroxyl group on carbon number 1 on the first carbon, and a methyl group on carbon number 3. So this is 3 methyl, 4 carbons in the stem, butan 1 all, butan 1 all there. Then 2.2.5 the structural formula of compound D there. So when you see a name, expect one of the questions to be asking you to draw the structure of that compound there. So to draw that ester there, we drew the ester there, ethyl propanoate. We said that we must have that ester linkage, from your from your functional group analysis there. Have the ester linkage. Once the ester linkage is here, then you ask the name. How many on the alcohol side? The starting part is the alcohol side. How many on the alcohol side? On the side here, this side here. Remember, this side can also be on the left. It's not about left or right. This part here, this part here. So how many carbons on that part? 1, 2. How many carbons on the acid side? Prop 3, 1, 2, 3. And then now let's put in the hydrogens to make sure that each carbon has 4 bonds around it there. This one is fine. And then like that there. Then you have just drawn the structural formula of an ester. 2.2.6 letters that represents a pair of compounds that are isomers, C and D. C and D, and then the type of isomers, functional isomers. Functional isomers there, ester and carboxylic acid, functional isomers there. All right, and let's see here. That's 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9, 10. All right, 10. 10. Okay.